breaking news.
A group of NTU students have made a tremendous discovery in the field of robots. They have created a robot which is able to explore and traverse an unknown area while avoiding obstacles along the way. Thereafter, it is able to plan and follow the fastest path from one point to another. This is all enabled by transmitting the control signals from a mobile device to the robot's body. Let's see what they have done. If we were to compare the robot to a human body, its body would comprise of a brain, heart, and nerves. In this scenario, the Arduino component acts as the body, PC as the brain, Nexus 7 as the heart, and Raspberry Pi as the nerves. Being the nerves, the Raspberry Pi links up the components. By sending everything to and fro the Raspberry Pi, the components do not communicate directly. Whereas the functions of the Arduino body are to sensor values and follow the commands of the PC. The PC is the brain in this system, planning and deciding on the fastest path to travel. Lastly, the heart is played by the Nexus 7. It has to be started before the robot can begin or stop to end the movement. Let the team members elaborate on the components they are in charge of.
Okay, hello, I'm Clement and I'm from the Raspberry Pi team. So the Pi is actually the central server whereby it routes all the different messages from PC as well as Android to Arduino and vice versa. So the PC and Pi is connected via Wi-Fi, and the Pi has a DHCP server which actually allocates an IP address to the PC. And then for the Android, it's connected via Bluetooth, and it will be sending and receiving commands from Pi and from Android. And for Arduino and Pi, it will be connected via serial.
Hello, my name is Joshua and I will explain to you about the Pi communication. Basically, we are using the multi-threading program for Pi, so that for each device, we'll have two threading, which is the receive from device and send to device thread. For each device, we'll allocate one buffer, so that if Arduino wants to send data to PC, then the Arduino buffer will be sent to PC. And for breakdown for each thread, you can see here, for the receiving thread, which is from the device to Pi, the accept function will keep looping, will just stay there if there is no incoming data. But if there is incoming data, then the next step will be run. For the send thread, which is the Pi to the device, it will wait for the source buffer. Let's say if Arduino wants to send to Android, then it will wait for Arduino buffer until it is filled, or else it will just keep looping there.
Hi, my name is Kim Fang and I'm doing the Arduino part for this project. Okay, I'm in charge of programming the Arduino and assembling the robot. For the Arduino, there are four main parts to it. Basically, get the sensor value, get the encoder value, serial communication, and movement. For serial communication, it will be used to transmit the command from the Raspberry Pi to the Arduino, and for the Arduino to send the sensor value to the Raspberry Pi. Then for the encoder is used for the PID to make sure that the robot is able to move in a straight line. And lastly, for the movement, there are three movements that the robot can move: go straight, turn left, and turn right.
Hi, I'm Kenneth and I'm actually from the Algo team. So we actually coded up the interface and basically I did the networking from the algorithm from the PC to the Arduino and Raspberry Pi. So basically what we did was to have sockets, and we actually opened sockets and send acknowledgement between the different systems to actually acknowledge that the messages have been sent to actually successfully move the robot.
My name is Chiu-Di. My job is find the shortest path when the robot going back from the original to start position. The basic idea is I build a graph based on the two-dimensional array of the map information and use the depth-tier algorithm to generate the shortest path.
Hello, my name is Wu. I will explain about the exploration algorithm. We choose the one following algorithm for the explorations. We just use the left and front sensor to detect the obstacle. If had any obstacle on the left, then we move forward. If each rig any obstacle on at the front, then we turn right. This has a limitation that is cannot explore all the arena, but it can move to the point correctly because the sensor can detect very easy.
Hi, I'm Huang Wei. In this project, Pamela and I were responsible for the remote controller, which is developing the Android application on Nexus 7. And we'll use the Nexus 7 to control the movements of the robot via Bluetooth. And at the same time, the app is going to render the maze environment explored by the robot. That's it.
Hi, I'm Pamela and I'm part of the Android team. One of the functions I created was the persistent data nature of the application. As stated in the requirement, the application had to save data even after it was closed and reopened. So now that we know how the robot and its components work, let's see how the robot fares.